Education is not the learning of facts, but the training of the mind to think. So let's learn and enjoy mathematics. Our lesson is about solving problems involving permutations. What could be our objectives? First, we will solve problems involving permutations. Second, we will apply permutations in real-life problems. Let us recall the different permutation formula. Permutation of n objects taking all at a time, that is P, it is equal to n factorial. Permutations of n objects taking r at a time, that is n factorial, all over the quantity n minus r factorial. Permutations with identical elements, that is distinguishable permutations, P, it is equal to n factorial all over n sub 1 factorial times n sub 2 factorial and so on, and n sub k factorial. And then the last, permutations in circular pattern. So that is circular permutations. P, it is equal to the quantity n minus 1 factorial. In example number 1, how many 5-letter code words can be made from the letters C, D, E, F, and G without repetition? Let us see what could be the given. The given letters, that is N, if we count those letters C, D, E, F, and G, we have 5 letters. And then R, that is equal to 5 because we need to identify how many 5-letter code words. So let us find out the permutations of 5 objects taking 5 at a time. The formula, it is equal to n factorial all over the quantity n minus r factorial. N, that is equal to 5, and then r, that is equal to 5. We replace all those numbers to the given equation. So permutations of 5 objects taking 5 at a time, it is equal to n, that is equal to 5 factorial, all over n, that is equal to 5, minus r, that is equal to 5, and then factorial. 5 minus 5, the answer is equal to 0 factorial, and then copy the numerator 5 factorial. 0 factorial, that is equal to 1, and then the factored form of 5 factorial, that is 5 times 4 times 3 times 2 times 1. If we multiply, the answer is equal to 120 divided by 1. 120 divided by 1 is also equal to 120 ways. In example number 2, how many 4-digit numbers can be formed from the digits 1, 2, 3, 5, 6, 8, and 9 if repetition is allowed and repetition is not allowed? Let us first solve repetition is allowed. We may use the formula for fundamental counting principle, that is n sub 1 times n sub 2 times n sub 3 times n sub 4. Why 4 up to n sub 4? Because we have 4-digit numbers. Based on letter A, repetition is allowed. So it means we may repeat those digits. How many digits? So 1, 2, 3, 4, 5, 6, 7. In the first digit number, so that is 7. In a second decision, for a second digit number, that is also equal to 7 because repetition is allowed. In the third decision, in a third digit number, that is also equal to 7. And fourth decision, in a 4-digit number, that is also equal to 7 because based on letter A, repetition is allowed. So let us multiply. 7 times 7 times 7 times 7, the answer is equal to 2,401 ways. How about repetition is not allowed? So the formula right now, permutations of n objects taken r at a time, it is equal to n factorial all over the quantity n minus r factorial. So this one, repetition is not allowed. So hindi pwedeng maulit. So what could be the value of n? N, that is equal to 7 because we have 7 digits. And r, that is equal to 4. So permutations of 7 objects taken 4 at a time. N, that is equal to 7. N, that is 7. And then R, that is equal to 4. So let us solve the denominator. 7 minus 4, that is 3 factorial. And then copy permutation of 7 objects taken 4 at a time. It is equal to 7 factorial all over 3 factorial. And then, saan ba tayo mag-stop in the numerator? So, mag-stop tayo to 3 factorial because para makancel yung 3 factorial in the denominator. So, that is 7 times 6 times 5 times 4 times 3 factorial. And then, we may cancel 3 factorial because that is equal to 1. So, let us multiply. 7 times 6 times 5 times 4, the answer is equal to 840 ways. In example number 3, there are 4 different Filipino books and 5 different English books. In how many ways can the books be arranged on a shelf if there are no restriction and books of the same subjects must be placed together? Let us first solve there are no restrictions. So the formula, P, it is equal to N factorial. It means no restrictions, so pwedeng mag-combine yung Filipino books and English books. So 4 plus 5, so we have N that is equal to 9. So P, it is equal to 9 factorial. And the 9 factorial in a factored form, that is equal to 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. If we multiply all those numbers, the answer is equal to 362,880 ways. How about for letter B? Books of the same subjects must be placed together. So what could be the formula? So P, it is equal to 4 factorial because we have 4 different Filipino books times 5 factorial because we have 5 different English books. Based on letter B, books of the same subject must be placed together. So it means, ang magkakatabi Filipino books. Ang magkakatabi lang English books. Okay. Times 2 factorial because kung magkakatabi yung Filipino books and English books, may magkakatabi sila. Dalawang palit yun. Filipino-English or English-Filipino. So we have 2 factorial. The 4 factorial, that equivalent is equal to 24 because 4 times 3 times 2 times 1. Times 5 factorial, that is equal to 120 because 5 times 4 times 3 times 2 times 1. And the 2 factorial, 2 times 1, the answer is equal to 2. 24 times 120 times 2, the permutation, that is equal to 5,760 ways. In example number 4, a license plate begins with 3 letters and 3 numbers. If the possible letters are all vowels only, and the number choices for each digit will only be odd numbers, how many different license plates can be made if no letter and number is used more than once? Let us give the illustration. The sample plate number, that is 3 letters and 3 numbers. And then the letters must be vowels only, that is A, E, I, O, U, and 3 positions available for the 3 letters. Sample letters are A, E, I, O, and then I, O, U. In the numbers, it should be 5 odd numbers. So the odd numbers is 1, 3, 5, 7, and 9. And 3 positions available for the odd numbers. Sample position, that is 1, 3, 5, 3, 5, 7, 5, 7, 9. So let us get now the permutation. So permutations of 5 objects, 5 vowel letters, taken 3 at a time because 3 positions available. While the numbers, permutations of 5 objects because we have 5 odd numbers, taken 3 at a time because 3 positions available for the numbers. So let us solve. So let us multiply permutations of 5 objects taking 3 at a time times permutations of 5 objects taking 3 at a time. Let us replace to the formula for the permutation, that is n factorial all over the quantity n minus r factorial. Same with the numbers, same formula. So let us replace the value of n by 5. So that is 5 factorial. The value of n by 5, that is 5 factorial. the value of r that is equal to 3 factorial. And then, parehas lang naman itong nasa right side, let us copy 5 factorial and then the quantity 5 minus 3 factorial. So let us solve the denominator. 5 minus 3, the answer is equal to 2 factorial. Also this one, 5 minus 3, the answer is equal to 2 factorial. And copy 5 factorial in the denominator. And then, mag-stop tayo to 2 factorial because the denominator is 2 factorial to cancel 2 factorial in the numerator. So that is 5 times 4 times 3 times 2 factorial. Also this one, let us copy. Parehas lang naman. So cancel 2 factorial and then cancel 2 factorial. So let us multiply. 5 times 4 times 3, the answer is equal to 60. 5 times 4 times 3, the answer is also equal to 60. 60 times 60, the answer is equal to 3,600. So 3,600 ways to get the different license plate if no letter and number is used more than once. How about example number 5? There are 12 people in a get-together. In how many ways can the host arrange his guests in the dining table if they can sit on any of the chairs? And letter B, 3 people insist on sitting beside each other. Let us first solve letter A. They can sit on any of the chairs. So the formula is a circular permutation because that is dining table. So that is P, it is equal to the quantity n minus 1 factorial. And that is equal to 12 because based on letter A, they can sit on any of the chairs. So 12 minus 1 factorial. 12 minus 1, that is equal to 11 factorial. And 11 factorial, that is 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. If we multiply all those numbers, the answer is equal to 39,916,800 ways. How about letter B? 3 people insist on sitting beside each other. So the formula for the circular permutation, that is equal to the quantity n minus 1 factorial times the restriction 3 people insist beside each other, so that is 3 factorial. So let us see in the illustration. So we have 12 people that is sit in the dining table. So n is equal to 12. But then example 10, 11, 12, 3 person insists on sitting beside each other, so they consider as 1. So right now, the people now is equal to 10. So n is equal to 10 because 3 people insist beside each other. So let us replace n to the given equation. So P, it is equal to the quantity 10 minus 1 factorial times 3 factorial. 10 minus 1, the equivalent is 9 factorial times 3 factorial. And the 9 factorial, that is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. If we multiply those numbers, the answer is equal to 362,880 times 3 factorial, that is 3 times 2 times 1. 3 times 2 times 1, the answer is equal to 6. So 362,880 times 6, the answer is equal to 2,177,280 ways. Instruction: solve the following problems using permutation. Provide your answers in the comment section. Enjoy learning mathematics. I'm Teresa Tubal. Thank you so much.